In this chapter, we talked about MANOVA. So MANOVA is used to detect group difference on several dependent variables. So MANOVA can use to reduce the family-wise error rate compared to the one-way ANOVA. So when we have two or more dependent variables and we want to use MANOVA, and also it should include three or more predicted variables. So in this chapter, I'm interested in looking at which type of therapies can most reduce the symptoms of the depressive disorder on the psychological and emotional and cognitive areas. So I have 30 participants who suffer from depressive disorder. So each participant receives one of three types of treatment for 8 weeks. So the first treatment group is a CBT, and second one is ACT, and third one is non-treatment group. So after end of the treatment, each participant has to take the interview. During the interview, a psychologist will make 3 readings regarding the psychological, emotional, and cognitive. So the higher score means higher functioning. So the first we want to see the correlationship between our dependent variables. The first comparison is psychological and emotional. We use the Pearson correlation test, and we can see the correlation is 0.94. And also we can see the comparison between the psychological and the cognitive, and the correlation is 0.13. So for our data requirement, the correlation should meet our data requirement. So the first function, we use the meta function to transform the data format to the wide format. So and for those two functions, we use to get a plot to have a better image of our data file. So as we can see, we have 3 treatment groups, and for each area they have a score on the scale. And as we can see, the CBT has higher score than ACT, and ACT has higher score than the non-treatment group. So later we can set the contrast group. So we want to compare the CBT to other groups, because we want to see if the CBT is the most effective treatment to deal with the depressive disorder. And also the second contrast group is the ACT compared to the non-treatment group. And also we can use the bi-function to get the descriptive stats. So similar to the plot, we can see for the psychological dependent variable, the CBT has higher median and means than other groups, and also similar to the emotional area, and the CBT has higher score, and also for the cognitive area. So right here we we want to create new variables, CBT, ACT, and non-treatment variables, to transform the data in order to run the Shapiro test. So right here we can see we got 3 Shapiro tests for each group, each variables we created, and all the p-values are less than 0.05, which means our data are not deviated from multivariable normality. So this function is used to detect the outlier of our data. So because each group has 10 participants, and three groups have the same participants, so we do not have to worry about the difference between the groups. And also from the plot we can see we don't have the outliers, and we use this function to set the factor for the group in order to set the contrast. So for the first contrast, we want to compare the CBT therapy to others, and the second one is ACT compared to non-treatment group. And we use this function to combine the contrast in the data file, and we create a single outcome which includes the psychological dependent variable and emotional dependent variable, and we create a model in order to run the MANOVA. So right here we get our first result. It shows that the p-value is significant less than 0.05. So we can make the conclusion that CBT had a significant effect on depression compared to other groups. However, it didn't tell us about which group differed from which, and it also didn't tell us whether if the effect of therapy was on psychological or emotional. So right here we run the summary function. We get the 2 p-values, and the first one is for the psychological, and the second one is for the emotional. As we can see, both the p-values are less than 0.0, significant less than 0.05. So in the univariate contrast, univariate test, we want to look at the contrast, and we create a model in order to see the summary. So right here, it's a psychological model. So as we can see, for the contrast, we set the CBT versus others. The p-value is less than 0.05, which means the CBT has significant effect on depression, but on the depression, especially for the psychological area. But for the second contrast group, the ACT versus non-treatment group, the p-value is above 0.05, which means there is no significant. We can make the conclusion that the ACT therapy on treating depression is not significant in the psychological area. So based on all the data we collected, we can make the conclusion that there was a significant effect of ACT therapy on treating depression people with emotional part, but not the psychological area. And also we can see that the CBT is the most effective therapy to deal with the depressive disorder compared to the ACT therapy. Even though we get all the p-values and all the significance, but we still want to do a follow-up, the discriminate analysis. So right here we can see the group sample size has been divided by the total sample size equally. So it's 1/3 for each. And also we can see from this data, it shows that the values are all the different, and we can see that the first variable differentiation group affects the dependent variables differently. So all of them affect the dependent variable differently. So finally, this data shows us the first variables account for 92%, and the second variable account for 0.07%. No, 7%. So similar to the first one we have done, so we want to move to the second MANOVA. So for the second MANOVA, we can compare the psychological to the cognitive, and so right here, as you can see, we set the 2 column and the 4th column. So by that we get this data. So the variance for the psychological and cognitive are a little different across the groups. But as we mentioned above, we don't need to worry about those differences because our group size are equal. So right here we also want to create the variables in order to run the Shapiro test. Again, all the p-values are above 0.05, which means that our data are not deviated from the multivariate normality. And this one is also to see the outlier. And we want to run the MANOVA, and it shows that the p-value is extremely less than 0.05, and it shows that the CBT is very